This is SpaceTime Series 27, Episode 46, for broadcast on the 15th of April 2024. Coming up on SpaceTime, a possible neutron star black hole merger detected in gravitational waves. A new study shows that stars often wind up eating their own planets. And the science from America's solar eclipse. All that and more coming up on SpaceTime.
Welcome to Space Time with Stuart Gary.
The LIGO-Virgo-KAGRA gravitational wave collaboration has detected what might be either the merger of two neutron stars, or even more excitingly, that of a neutron star with a stellar mass black hole. The signal was initially detected back in May 2023, just days after the fourth LIGO gravitational wave observatory run began. The LIGO-Livingston gravitational wave detector observed the signal from a collision of what's most likely a neutron star with a compact object between 2.5 and 4.5 times the mass of the Sun, at a distance of roughly 450 million light-years. Now, unfortunately, the direction of the source could not be determined because only one gravitational wave detector, LIGO-Livingston, was observing at the time of the signal. Neutron stars and stellar mass black holes are both compact objects, the dense remnants of massive stellar explosions. But what makes this signal, catalogued as GW230529, so intriguing is the mass of the heavier object. It falls within a possible mass gap between the most massive known neutron stars and the smallest stellar mass black holes. The trouble is the gravitational wave signal alone cannot reveal the nature of this object. Further detections of similar events, especially those accompanied by bursts of electromagnetic radiation, could hold the key to solving this cosmic mystery. One of the study's authors, Jess McIver from the University of British Columbia, says the detection reveals that there may be higher rates of similar collisions, that is, between neutron stars and low-mass black holes, than previously thought. Before the detection of gravitational waves in 2015, the masses of stellar mass black holes were primarily found using X-ray observations, while the masses of neutron stars were obtained using radio observations. The resulting measurements meant the objects fell into two distinct mass ranges, with a gap between them being somewhere between 2 and 5 times the mass of our Sun. Over the years, a small number of measurements have encroached on this mass gap, which remains highly debated among astrophysicists. Analysis of the signal from GW230529 shows that it did come from the merger of two compact objects, one with a mass somewhere between 1.2 and 2 times that of our Sun, and the other slightly more than twice as massive. Now, neutron stars are known to have masses between 1.44 and 2.3 times the mass of the Sun. 1.44 being the magic Chandrasekhar limit, beyond which baryonic particles can push through the electron degeneracy barrier, which prevents two particles from occupying the same quantum space at the same time. And we now know that masses above somewhere around 2.3 solar masses, maybe 2.4, are thought to be capable of breaking the neutron degeneracy barrier, allowing them to crush down far enough to become black hole singularities. Now, while the gravitational wave signal doesn't provide enough information to determine with any degree of certainty whether or not the compact objects are neutron stars and black holes, it seems very likely that the lighter object is most likely a neutron star, and the heavier one probably a black hole. The study's authors are confident the heavier object is within the mass gap. Gravitational wave observations have now provided almost 200 measurements of compact object masses. Of these, only one other merger may have involved a mass gap compact object. The signal GW190814 came from the merger of a black hole with a compact object exceeding the mass of the heaviest known neutron star, and possibly within the mass gap. While previous evidence of mass gap objects have been reported both in gravitational waves and electromagnetic waves, this system is especially exciting because it's the first gravitational wave detection of a mass gap object paired with a neutron star. The observations therefore have important implications, both for theories of binary evolution and electromagnetic counterparts to compact object mergers. The highly successful third observation run of gravitational wave detections ended in early 2020, bringing the number of known gravitational wave detections to 90. Before the start of the fourth observing run on the 24th of May 2023, the LIGO-Virgo-KAGRA researchers made further improvements to the detectors, the cyber infrastructure, and the analysis software, allowing them to detect signals from further away and to extract more information about these extreme events which these waves generated. The current fourth observing run's planned to last a total of 20 months, including a couple of months' break to carry out maintenance of the detectors and to make a number of necessary improvements. By January the 16th, 2024, when the commissioning break started, a total of 81 significant signal candidates had been identified, and GW230529 is the first of these to be published. This is SpaceTime. Still to come, a new study shows that stars often eat their own planets. And as much of the world marvelled at last week's total solar eclipse of the sun across North America, scientists were busy carrying out new observations. We'll tell you what they were up to. All that and more still to come on SpaceTime. A new study has confirmed that at least 1 in every dozen or so stars have torn apart and consumed one of their orbiting planets. The findings, reported in the journal Nature, are based on a study of binary star systems which should contain 2 stars with an identical composition. However, in about 8% of cases, they apparently differ, a finding which has been perplexing scientists. Astronomers have now found that the difference could be due to one of the stars in the group devouring planets or planetary material. The study's lead author, Fan Liu from Monash University, says his team were examining twin stars travelling together. They're born at the same time in the same molecular gas and dust clouds, so they should be identical. However, high-precision analysis has allowed the authors to detect chemical differences between the pair. Liu says this provides strong evidence that one of the stars has swallowed either planets or planetary material, and that's changed its composition. He says the same phenomenon appeared in about 8% of the 91 pairs of twin stars the team looked at. What makes this study compelling is that the stars were all in their prime of life, on the so-called main sequence, rather than stars in the final phases of their existence, such as red giants. Stars on the main sequence are fusing hydrogen into helium in their cores, whereas red giants are known to consume nearby planets as they expand and become bloated in the final stages of their lives. Now, there is some room for doubt as to whether the stars are swallowing planets whole or whether they're simply engulfing protoplanetary material, but Liu suspects both are possible. He says it's complicated. The ingestion of the whole planet is the favoured scenario, but the team can't rule out that some of these stars are ingesting lots of material from a protoplanetary disk. The findings have been made possible thanks to a large dataset collected with the help of the 6.5-metre Magellan telescope and the European Southern Observatory's Very Large Telescope, both in Chile, and the 10-metre Keck telescope in Hawaii. Liu says the research forms part of a larger collaboration known as the Complete Census of Co-Moving Pairs of Objects, or C3PO, and top prizes for whoever came up with that one. It's an initiative to spectroscopically observe a complete sample of all bright co-moving stars identified by the European Space Agency's Gaia astrometric satellite.
We are basically just looking at some stars which are just like twins. So they were born together and moving around together. So we call them conatal systems. They should have be basically identical, have the same composition. But actually we do find some differences in terms of their chemical composition. So from there we notice that some of those twin stars, or one of them, seems to have a higher amount of some material and elements, and that could be due to the ingestion of planets. So we found that to be very interesting, because it's kind of not very commonly seen before.
How common is it? How often does it happen?
So it's surprising because we do know when stars evolve to the late stage, they will turn to a giant ball and they will eventually swallow their planet. But for our study, we mainly looked at the stars at their early or mid age, so that they are at their main sequence stage. So in this stage, it's actually uncommon because we used to believe this kind of stellar planetary system should be very stable, just like our solar system, very stable and nothing intense would happen. And but actually, from our study, we see that it's actually happening. So at some stage, like some of these like inner planets can be just scattered into its star, like due to maybe some instability.
You've got two stars. They're in a binary system. They're orbiting each other. Both stars are still on the main sequence. One of them hasn't become a red giant yet or anything. Is that correct?
Yeah. So both stars are at the same stage. So they are like, so they were born together. So they have same age as well. So they have the same. They should have same composition. But then we see the difference. So then from there we can say that there's some like planetary ingestion happened.
Something's happened, and if they're both at the same, that means they're both at the same mass, I take it, if they're the same stage of evolution.
Yeah. They basically have the very same evolution, mass, and everything very similar. Yeah.
And yet, when you look at these stars, when you do a spectra of them, you find that one star contains the sorts of elements you normally see in a planet, gas or terrestrial planet, I guess I should be asking.
Yes, indeed. So like they are mainly like elements from like terrestrial planets, like like iron, nickel, silicon, and aluminium. So sort of like kind of rocky material and rocky elements.
We'd expect to see this in a star once it moves off the main sequence and becomes a red giant or a red supergiant, but to see it in a main sequence star, that's got to mean there's some sort of gravitational perturbation involving the orbit of the planet and the stars themselves.
Yes, indeed. That's kind of one of the very important implications of this study. So it helps people to understand like the instabilities in like the stellar planetary system.
I guess the next thing to do is find more examples of this.
Yes, indeed. We are looking forward to like examine like more systems like this. Meanwhile, we are also trying to, for example, search for like monitoring the radial velocity variation of like this system we have already identified, because we know that they must have some like perturbers there. So it could be a super Earth or it could be a giant or something like a planet, something like that. So we're also trying to find those sort of perturbers in those systems we identify.
How were you able to do the research?
We have like spent actually quite a lot of efforts like to collect all of this very high quality spectral data. They were like all taken from like those like international like large telescopes in like Hawaii and in Chile. And then we are also looking into like other like coordinator systems. Like for example, we are looking into our sun's coordinator system, because previously we don't know exactly how many like are really the sun's coordinator systems, but now we have some techniques that we can probably identify them and then apply some analysis to check if our sun has some peculiar chemical composition.
Our nearest neighboring star system, Alpha Centauri, it has two stars very similar to each other, Alpha Centauri A and B. We know that the third star in the group, Proxima Centauri, has planets. We don't know yet if Alpha Centauri A and B have planets, do we?
We don't know for sure. That's probably one which is very further away, like those kind of very far away, further away planning, but we can't really confirm that yet.
Is that a system you're going to be looking at?
Yes, Alpha Centauri would also be another very interesting system to look into, indeed. So to apply like some analysis and to compare them to, for example, some stars which have very similar properties of like other stars which, they were like born together. Yeah.
That's Fan Liu from Monash University. And this is Space Time. Still to come, we look at the sort of science astronomers are up to during last week's solar eclipse. And later in the science report, anthropologists have discovered Australia's oldest pottery, dating back to between 2,000 and 3,000 years ago. All that and more still to come on Space Time. As much of the world marvelled at last week's total solar eclipse of the sun across North America, scientists were busy carrying out new observations. The breathtaking display has come as the sun's nearing the peak of its 11-year solar cycle. And spectators weren't disappointed, with a solar corona glowing spectacularly from the moon's silhouette along the path of totality. The total solar eclipse began in the Pacific Ocean, sweeping across North America after making landfall in Mexico. It then arced through the southwest, midwest, and New England regions of the United States before crossing into eastern Canada and then heading out to sea from Newfoundland. Eclipse watchers in Mexico got the longest period of totality, when the moon completely blocks out the sun. That lasted some 4 minutes and 28 seconds. But most places along the path of totality saw durations of between 3.5 and 4 minutes. As well as undertaking more than 40 citizen scientist projects, NASA launched a small armada of rockets, jets and drones to monitor the spectacle in greater detail. The agency launched no less than 3 Black Brant 9 sounding rockets from the Wallops Flight Facility on the Virginian mid-Atlantic coast, and a specially equipped drone was deployed from Fort Drum in New York State. The rockets were sent up before, during and just after the eclipse to investigate the influence of solar eclipses on the Earth's upper atmosphere, including atmospheric response to the transient absence of sunlight. NASA also flew its WB-57 jets to chase the eclipse from altitudes of above 50,000 feet. That was in order to gather data for scientists wanting to better understand the solar corona and its effects on Earth. The jet's missions were designed to shed light on the corona's structure, its temperature, and the solar wind's origins through spectrometers and cameras. They also studied the ionosphere's behavior under the shadow of the moon, potentially enhancing science's comprehension of the solar radiation's impact on crucial technologies like radar and GPS. But it doesn't end there. The agency also used a specially equipped drone fitted with an array of weather sensors similar to those used by the National Weather Service on daily weather balloon flights to collect data on temperature, relative humidity, pressure, and winds. The aircraft was flown to its maximum altitude, nearly 3.2 kilometers, in order to test an alternative data collection method from that of standard weather balloons higher in the troposphere, the lowest part of Earth's atmosphere where the weather occurs. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with the Science Report. A new study warns that we're likely underestimating the future impact of so-called forever chemicals in the environment. A report in the journal Nature Geoscience warns that per- and polyfluoroalkyl substances are now at levels in global water resources which far exceed safe drinking limits. These forever chemicals have been in widespread production since the 1950s, and it's now thought that every human being on this planet has been contaminated by them to some degree. They've been popular because of their ability to resist heat, water, grease, and stains. In fact, over 14,000 different types of chemical combinations have been developed from these per- and polyfluoroalkyl substances. They've found their way into products ranging from some types of firefighting foams to non-stick fry pans, carpets, leather and apparel, textiles, paper and packaging, coatings, rubber, food processing, and plastics. The study, led by the University of New South Wales, assessed the levels of forever chemical contamination in both surface and groundwater around the globe. A new study has shown that the diabetes drug semaglutide, which is best known for its weight loss properties, can also help reduce heart failure-related symptoms and physical limitations in obese people with diabetes, as well as increasing their weight loss. A report in the New England Journal of Medicine looked at around 600 diabetics with heart failure who are also obese, giving them either once-weekly semaglutide treatment or a placebo for a year. After 12 months, they found fewer symptoms and physical limitations in the semaglutide group, and this group also reduced their body weight by around 9.8% compared to just 3.4% for those with a placebo. Anthropologists have discovered Australia's oldest pottery, dating back to between 2,000 and 3,000 years ago. The discovery was made on Lizard Island in the Great Barrier Reef. A report in the journal Quaternary Science Reviews claims the findings challenge the notion that Aboriginal Australian communities were unaware of pottery manufacture before European settlement. The pottery was locally produced using local clays. The discovery sheds light on the sophisticated maritime capabilities and trading systems of First Nations communities in North Queensland connected with the pottery-making communities of New Guinea. The highly prestigious Mayo Clinic has been slammed for allowing a staff nurse to promote the rank pseudoscience of Reiki. Tim Mendham from Australian Skeptics says the normally respected medical facility is being criticised by health professionals around the world for allowing the fake and unproven alternative medicine practice to be promoted under its banner.
This is pretty depressing, but it's not actually that unusual in a way. Mayo Clinic is, of course, a very prestigious medical facility in the US. It's generally regarded as one of the best clinical organisations in the US. It rates very, very highly, often up near the top, if not at the top. And it's also very innovative in the way it sort of develops treatment. And it has done since its sort of foundation 100 plus years ago. It is therefore strange and sad to see it then promoting, or to have people within it promoting some very, very dodgy alternative treatment. And what is even worse, and something that has been pointed out, is that the organisations themselves are not saying, hang on. The people within, sort of, who are not necessarily believers in some of these treatments, are not actually sort of pulling it up. And they've been described by some people as shruggies, like, I don't know, shrug their shoulders and say, yeah, well, that might be true. In particular, what's happened recently is someone putting forward supposed evidence for Reiki, which is an Asian practice of moving your hands over someone's body, not touching the body, so it's not touchy-feely. It's moving your hands over the body to disrupt energy flows and bad energy flows and push them away. In some cases, actually, it was almost literally sort of moving your hands and then pushing this energy down to the end of them and outside of their body. It's nonsense. Okay, as much as you can say, anything in the medical world is pretty lacking any sort of basis at all. There might be a placebo effect, it might make people feel good, but this is actually supposedly being touted as scientifically proven in this information coming out of the Mayo Clinic, or at least one particular researcher in the Mayo Clinic. This has been written by a nurse in the clinic named Kenneth Ruth, who has sort of been promoting this particular stuff. The trouble is the energy cannot be detected, it can't be measured, it can't be confirmed in any way. There isn't an energy-based practice that's been shown to have any effect beyond placebo, which is what this might be. But nonetheless, from a Mayo Clinic, which is heavily evidence-based, heavily medical evidence, science evidence-based, with innovative technologies that have been proven to work, and they've been involved in a lot of different areas, to have at least one person within the organisation promoting pseudoscience that is totally without foundation and running off that imprimatur of the Mayo Clinic is a concern. Now, it happens in lots of places. You'll get rogue
we heard
people.
about it with the World Health Organization too recently.
With the World Health Organization, which is almost sort of coming from the top there, but you find within most scientific organisations there will be someone who's a loose cannon. But this is someone claiming that it's scientifically proved, that there's a whole range of medical papers, blah, 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 that are actually proving this thing, which are not. So it's one thing to be promoting a totally unproven and disproven in some cases, but sort of tenuous treatment system, but then to have it coming out of such a prestigious body, that's where the problem and the concern lies.
It gives credibility to something that doesn't deserve it.
Absolutely, and it's extreme credibility because, as I said, the Mayo Clinic rates very, very highly amongst medical facilities in the US, but the claims are just not supported, and there's no indication that the practitioners, who are often just trained in Reiki, they're nothing any great medical qualification. It's very sad. I mean, the evidence that's been put forward is largely anecdotal, and which means that you really can't sort of study it scientifically, and you certainly can't prove it beyond sort of a nice feeling.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTime with Stuart Gary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.